Hi there, and welcome to video number 3 from this worksheet. This one. Okay, now on page 2, or worksheet number 2. This one looks like fun because it says, make a tree diagram for each problem below, listing all possible outcomes. I'm not good at tree diagrams, so let's see how this can work. They're really good when your questions start to have, if this happens, then do this. If something else happens, then it's a completely different set of outcomes. But let's just see. A quiz consists of 4 true, false questions. How many possible answer keys? Make a tree diagram to show all possible answers. Okay, so tree diagrams. So this is worksheet 2. Question 1. All right, start. Now it was a true false quiz, and there's 4 questions. I need more room. It's my start, so I'm going to answer my first question, and it's either going to be true or it's going to be false. This. I'm sensing this question, so I'm going to take up a lot of paper. First question. Now I got to do second question. So this one. If I answered the first one true, then my second one could be true or false. False. There's my second. Whoa, move it, move it, move it. I think you're getting the idea. So for my third question, here we go. And there were 4. So one more time. Oh no. Oh, wait, it says, I have to read my question carefully. Make a true diagram to show all possible answers. It doesn't say I have to list them all. There should be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 16. Good. Okay, so if you're not sure, it could be true, 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 false, true, true, false, true, 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 false, false. I'm not doing them all, but you get the idea. If it didn't say show a tree diagram, I would have just done fundamental counting. First question, second, third, fourth. 2 choices for my first one, true or false. 2 choices for my second one, true or false. And 2 and 2. You see 16 all together. So, ta-da, there we go. Yeah. New question, new page. All right, question 2. A box containing 2 $1 bills, a $5 bill, and a $10 bill. So that's 4 bills altogether. 2 bills are selected in succession without replacing the first one. Draw a T diagram to represent all the possible amounts of money that can be selected. All right. So number 2. There's $1, $1, another $1, and $5, and a $10. So that's 4 things. So here's my start. So I'm going to pull out the first bill. What choices have I got? Remember, I'm drawing the tree diagrams. I have to actually list them out. I could do $1. I may regret not making this bigger. $1, a $5, or a $10. Okay. So I pulled one out, and we don't replace it when we pull it. So after I pull this one out, there should be 3 left in the box. There we go, 3 left in the box. So those are my choices. It's not 4 again, right? Not like the first question, where every single time it could be true or false. There was no options. Here, I've taken one out. So I could get the other $1 bill. I could get the $5, or I should get the 10. I'm not writing the dollar sign anymore. Same thing here. $1, $5, $10. Here I could choose a $1, $1, or the 10. And I could choose the $1, $1, and the 5 as my second choice. So that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should stop counting out loud for you. I know you can do that part. Okay, so 12 choices. So you could get $1 and $1, you get $1 and a $5, you get $1 and a $10. And then that would be a repeat. You get the idea. Mathematically, if it didn't say draw the diagram, it would be first bill, second bill. So there were 4 to start out with. And then I kept 1, I didn't replace it. So that's 3. And ta-da, we got 12 choices. All right, number 2. Number 3. List all the possible outcomes of a 5-game series played between the Pirates and the Yankees. Note the winner is the first team to win 3 games. Not 100, sorry. Not 100% sure where that's going, but let's figure it out. It says draw a tree diagram, so that's where we're going to start. Okay, and we are going to be the Pirates. Point of view. Okay, and I want to put that in there because I'm talking about win and loss, and I don't want to go, the Pirates won, the Yankees lost every time. It just should be simpler. We'll see. Guess I haven't done these questions at a time, so we'll see how this goes. Well, game 1. Pirates win, Pirates lose. Okay, I already screwed up. We can't win. It's win or loss. Game 2. Game 3, here we go. This question's crazy. It's a 5-game series. Oh, I know where they're going. Okay, I'm going to finish the diagram and then we'll see how little I know about sports. It's getting squishy. That's game 4. I probably should have told you to pause the video so that you can do this on your own and not watching me do it, especially with no commentary because I'm concentrating. Okay, there's the ridiculous diagram. Oh, you know what? I bet there's 32 choices there. I bet there is because it's 5 games, 2 choices, win or loss. Yeah, there's gonna be 32. Okay. So it says the winner is the first team to win 3 games. I think I would not give you this on a test question, but we're going to trace it through and see how often the Pirates win or the other guys win. So 3 in a row. So 1, 2, 3. Pirates won. And then we don't have to worry about those ones because those games would never have been played. Now let's try 3 wins. Done. So I think, hold on. Yeah, so these guys wouldn't matter. Oh, this is where Joanne gets in trouble. So we can go win, another win, and then a loss. And then they get a win. So that would be Pirates again. And then these ones would matter. Sorry, wouldn't get played. These ones wouldn't get played. Now I can go a win and a win and a loss and a loss. Okay, so it's tied at 2 and 2. And then a win. That would be Pirates. And I'm gonna stop. I'm gonna do this later on my own because I think I'm about to make a mess of it. What I would never ask you this question. I would go a 3-game series because this is too long to do. So have a lovely, no, I'm gonna stop the video. I literally will fix this later. So what do we want to know? Possibilities, 1, 2, 3, 4, 5. Game 1. 2 choices, 2 choices, 2 choices, 2 choices, 2 choices. 32 choices. I would suspect mathematically that if we went through all of this, there should be probably 16 times that the Pirates win and 16 times that the Yankees win. But I will not force you to do that. We're going to do question 4. Three balls numbered 1, 2, and 3 are put in the box. The box is shaken. And the balls are drawn out in sequence without replacement. Draw a tree diagram to find all possible 3-digit numbers. Okay, this one seems reasonable. It feels mathy. It's not about sports. Question 4. It's my start. Get smarter, put it in the middle of the page. And it's 1, 2, and 3. So pull out 1, pull out 2, pull out 3. First ball. And they are drawn out in sequence without replacement. Okay. So if I pull the 1 first, then we have the 2 and the 3 left. If we pull out the 2 first, then I've got the 1 and the 3 left. If I pull out the 3 first, yeah, you know it. I've got the 1 and the 2. Yeah, there we go. All right. So then our last one, there's only one choice. I pull 1 and a 2. That must be a 3. A 1, a 3, and a 2. 2, 1, I'm missing the 3. 2, 3, I'm missing the 1. 3, 1, missing a 2. 3, 2, and 1. Find all the possible 3-digit numbers. Okay. So I will write them out this time because there's not that many. 1, 2, 3. 1, 3, 2. And then we've got 2, 1, 3. 2, 3, 1. And finally, we've got 3, 1, 2. And 3, 2, 1. So a grand total of 6 numbers. If we wanted to not draw a tree diagram and just figure out how many instead of what the actual combinations are, you would just go 1, 2, 3. What are we doing? 3 balls. First ball, second, third. So there's 3 choices when I start. I pull 1 out, can't put it back. Then there's 2, and then there's 1. That's 6. Ta-da! And I hope maybe that made sense. Because, right, we had 3 choices to start. And then once we pulled that first one out, there's only 2 left. And after we take that one, there was only 1 left at the end. Number 4. Number 5. Again, I don't know what I'm going to show you. Worksheet 2, tree diagrams. A coin is tossed. If it comes up heads, it is tossed again. If it lands tails, a die is rolled once. Oh, I know that one's in the worksheet in the notes somewhere, but we'll do it anyway. So start. What happens? Coin is tossed. Heads, tails. If it comes up heads, it is tossed again. Heads, tails. If it comes up tails, a dice is rolled once. Sorry, that got messy. Find all possible outcomes of the sequence of events. Okay, I'm going to write them out. We can have heads and heads. Heads and tails. I'm going to have tails in 1, tails in 2, tails in 3. So that gives us 8 possible outcomes. And I'm not really sure how to do this without using a tree diagram, simply because if heads happens, then you have to do this next. If tails, it's something different. Yeah, no, I don't think you can. All right, we're getting there. I think this is going to be a long video because I want to finish this worksheet up. Students will start showing up, so I better get this done. The college is beginning to develop its intercollegiate athletics program. The school is predominantly female in composition, and hence the authorities felt that with a total of 7 sports, 4 should be for women and 3 for men. Okay. These sports are added to the program one at a time in such a way that the number of sports for women always strictly outnumbers the number of sports for men. In how many ways can the sports be introduced into the program, distinguishing them only by gender involved? Make a tree diagram. All right, I'm going to fess up. I paused the video. I did the question myself because it does not look like a normal tree diagram. But I feel confident now being able to explain this to you. So this is question 6. All right, so here's our start. And the rule is no matter what, there always has to be more women's teams than men's. So we're starting out, you know what? We have to have a women's team. Now when we go to do the next team, so this is the first team. So it's introduced. If I put them, right, traditionally I would go like men's and women's, but if I put a men's team next, then the women are not in the majority. So my second team also has to be women, right? Because if I went, women and then men, then there's an equal number and that's not cool. So, and I've got my answer key over here just in case it gets weird. Once I've gone this far, now I can actually make a choice. I could have a men's team or I could have a women's team. Because if I follow my path, I have 2 women and a men's team. We outnumber the men. Check. If we go this way, yes, we're still outnumbering the men. Now, from this man's team, if I put a women's team, then we got 1, 2, 3 women, 1 guy. We're outnumbering. Sorry, I'm referring to myself as part of this team. If I put a man, I can't put a man's team because if I do, then it's 2 and 2 and it's equal. So can't go any farther. And if we go this route down here, women's. Okay, so this is my second, by the way. And this obviously is my third team. Women. I could do a man, or I could do women, and do a woman down there, right? Because it's 1, 2, 3 women and a guy, and this is 1, 2, 3, 4 women. Done. So this is my 4th team. This is a bit of a brain burner. I kind of like this. All right. Now, let's see. I'm going to go back up to the top. So 15. There's 7. This is crazy. 1, 2, 3. Okay, so I got 3 women. So it's okay if I have a men's team, because that would be 3 women, 2 men's team. Or I could have the other woman's team, in which case 1, 2, 3. No, 1, 2, 3, 4, 5, and only 1 guy. So we're still good. Yeah, let's see what's going on down here. Woman, 3 women, and then a guy. So that's 3 and 2. I could have another guy, another men's team, or I could have a woman's team. So 1, 2, 3, 4, 5. So 3 women, 2 guys. That's cool. 3, 4 women, 1 guy. That's okay too. We're still in the majority. And when I go down to do this one, you know what? I cannot have any more women's teams because there's only 4. So I know at this one, I'm just going to finish it off. Men's. 4th, 5th, 6th, 7th. Ooh. But I know men's, because we got to get the men in there. So that strand is done. I'm going to go back up to the top. 1, 2, 3. Okay, I could throw another women's team, which would make 1, 2, 3, 4 women. However, if I try and put a men's team here, there'll be 1, 2, 3 women and 3 guys, and that's not allowed. All right, so that's, whoops, should be over for that, so 16. All right, let's try this branch. I don't know how to do this without this crazy figuring it out each time. 1, 2, 3, 4. Okay, so, whoops. 1, 2, 3, 4 women. I already have 1 guy. So that must mean I need a men's and a men's. So 1, 2, 3, 4 women, 1, 2, 3 men. We're good. This is 7. It's done. I'm going to count this one. 1, 2, 3, 4, 5, 6. Oops. We're missing 1. And it must be the men's. 1, 2, 3, 4 women. 1, 2, 3 men. Check. Now let's see what's going on here in the middle. 1, 2, 3 women. 2 guys. I can't put a guy men's next because it won't work. Then be 3 and 3. So it's got to be a woman's. Let's see. 1, 2, 3, 4 women. Check. 2 guys. That's all right. And we are missing 1 men's team. So 1, 2, 3, 4, 5, 6, 7. We're golden. Done. All right. I think this is my last one. 1, 2, 3, 4, 5 altogether. But I've got 1, 2, 3, 4 women already. So then my last 2 teams got to be men's and men's. Wow, that hurt my brain. And maybe there's a way to figure this out without drawing a diagram, but I got nothing. I have no idea how you do that. All right, there's one more question on this page, and I want to try it out because I've seen it, excuse me, and I've never actually done the question. So we'll see how this goes. A woman is going through a buffet line and intends, sorry about the voice, and intends to choose a main, a salad, and a beverage from the following. Okay. The woman refuses to eat Waldorf salad with lasagna, and if she does not choose lasagna, then she will select Freshka, but not macaroni salad. Wow, this is kind of goofy. Bless their heart, whoever made this up. Now, start at the beginning. Question 7. We are going to choose the mains. Make a big diagram. Whoops. Never mind. Big diagram so we can see. I probably screwed that up already. Okay. She can choose spaghetti, lasagna, ravioli. Check. Okay. Now, salads. And yeah, macaroni, Waldorf, just, and potato. You know what? I'm going to try something here. Macaroni. I may regret this. Macaroni, Waldorf, just, potato. And then I'm going to put in, I may regret this. I'm going to put in all my options, and then we're just going to cross out some because trying to keep all the it's too much writing for me. Coke and Freshka. Oopsies. Coke, Freshka, Coke, Freshka, Coke, Freshka, Coke. And I'm wishing I made my diagram bigger. Right, small, which one? Right. Okay, so there is a big mess of what she's eating. The woman refuses to eat Waldorf salad with lasagna. Okay, so there's lasagna, there's Waldorf. So we're just going to take that out. That doesn't happen. Check. If she does not choose lasagna, so that must mean these two, then she will select Freshka. Okay, so Coke disappears out of all of these. I'm thinking, I'm second guess myself, this is the easiest, but not macaroni salad. So the macaroni salad is just gone. I'll just take that all out. Construct a tree diagram to illustrate all the possible ways. All right, spaghetti, Waldorf Freshka, spaghetti, tossed Freshka, spaghetti, potato Freshka. But if she chooses lasagna, macaroni, Coke or Freshka. Okay, you get it. I'm not going through the whole list, but there you go. And I have no idea how I'm going to type this up as an answer key. But that's the end of the worksheet. So y'all have a great day. Be good. Be kind.